All right, we are in day 2 of adding and subtracting our rational expressions. And I know usually after day 1, it's a little bit frustrating of a task that we're taking on. So I wanted to take an opportunity here to get you some help. So the first thing we're going to do, excuse me, is to look through the green sheet that you got, which is called Building LCDs and Using Them for Addition and Subtraction. It goes back over the steps that we had before and kind of chats a little bit about this. So just as a quick review from yesterday, number 1, we're going to look for coefficients, if there are any. So example, if I had a 4 and a 6 that were sitting there, my LCD would be 12. Like, wait, how's my LCD 12? Remember, finding a least common denominator, okay, well, our least common multiple would be in this case. If I started to count by 4s and by 6s, what's the first number that would show up in both lists? That's how we're trying to find that numeric value for our common denominator. Number 2, we're looking for single exponents. Or I guess I should be calling those single variables. Okay? Not bound by plus or minus, not in parentheses. We're going to use the one with the biggest exponent. So if I see an x squared and x to the third hanging around, I use x to the third because it's the bigger one. And then finally, we use unique quantities or unique sets of parentheses. We use them one each unless there's a squared in the same set of parentheses, because it kind of goes as the same rule that the variables do. I use the bigger exponent. If I see a squared on a set of parentheses, I got to use that. So we're going to take a look at 3 of these to try and find the LCD and build these, and then we're going to work into your worksheet today, and hopefully we'll get you feeling more comfortable by the end of the class period today. So okay, first one. We're not even going to worry about building yet. We're just worrying about the LCD. So I worked down my checklist. Okay, coefficients. I got 3 and 5. What number would be part of my common denominator in this case? Now again, if you don't know off the top of your head and you need to write down 3 and 5 and start jotting some numbers down until you find something that's the same in both, that's fine. Okay, so here my LCD, numeric part, the coefficient would be 15. Then I'd look for single variable terms. Again, not in parentheses. Take the bigger one. There are no sets of parentheses, there are no quantities, so that's going to be my LCD. So like we did yesterday, we now go into fraction builder mode. Okay, that's going to be my common denominator. That's not going to change. The 2 and the 8 that I had at the start of this doesn't change. That stays the same way too. And my job now becomes to be kind of solving the puzzle, solving the mystery of what do I have to multiply 3 by to get to this. In other words, and I'll do a little side work here, 3x squared times something equals 15x squared. Whatever that value is, in this case, that would be 5, because I already have the x squared, and 3 times 5 is 15. That's the value that's going to go into my numerator to keep equality. And I'm going to play that same game on the next part. So how do I get from 5x times something equals 15x squared? Well, 5 times 3 is 15, and x times x is x squared. So that's the value that I'm putting up here. Now, if you're more comfortable doing the side work to see how that works and then building it, that's great. If you can visually do it, that's super too. Excuse me. And then we just simplify it. So I look, 2 times 5 is 10. 8 times 3x is 24x. And I keep my parentheses because there's a plus here now. These aren't individual factors anymore for what I'm doing. But then the question always remains, can I factor this sum? And if I can, I need to do that. And in this case, I could still take a 2 out of both of those. So I take the 2 out that they have in common. 2 times 5 gets me to 10. 2 times 12 gets me to 24. And once I've done that, I take my last peek. I say, okay, is there something that I can cancel? But what's in the parentheses is off limits, because I don't see another 5 plus 12x anywhere. So here's the only place I could do anything, and 2 doesn't go into 15. So that's as far as I can go. Okay? But you do. It's a process. It's not something that's just lickety-split and I'm done. There's not a shortcut. Okay, the biggest shortcut you may ever run into is you may be able to go from this step straight to here if you're good at your mental math and being able to work that out a bit. So move down a little bit more here, for example, 2. Same thing. I'm always going to cover up the numerator, and I ask myself, can I factor either denominator? Well, the second one, I can take a 2 out of both of those. Again, I scribble out the old one so I don't get confused as I'm working along. And I go to build my LCD from this. So, do I have any coefficients? I have 1. So I take that 2 out. Do I have any single variable terms? Nope. All my variables are stuck in parentheses, stuck in quantities. So then I look and I go, okay, I need these last 2. And that's going to be my LCD. So just like before, and I'll slow down here for a second once I get this jotted down. And again, that checklist is going to be there for you, so just, use it. Worst thing you can do with these is just kind of skip and go, I don't get it right away, I quit. Can't do that. Okay, again, no canceling until the end. Don't try to reduce the 4 and the 2 or the 2 and the 2. And again, as I go, if you're comfortable doing the horizontal like we did up here, go ahead and do that off to the side. But otherwise, again, I can just check off the pieces to the puzzle that I have, and whatever doesn't get checked off gets placed into my numerator. And I do that for both of these. Okay, here I got the 2, I got the x minus 4, I need the x plus 3. Now, it's personal preference here again. It's up to you on how you want to do it. To me, I like doing a little bit of side work and then coming back to this part just so I don't get myself messed up. Here's what I mean. So here, 4 times 2 is 8. So I'm cleaning up 8 times x minus 4. So we'll do that here to the side. I'm cleaning this up. Now, could I write all that along here and put that under? Sure, and actually I guess I will in this case. Just so I can see what's going on with all of this. Now again, I'm still not at a point where I'm going to cancel anything. I want it simplified completely in the numerator and denominator before I do that. But again, if you wanted to put those together and go to like terms right away, that could save you a step. So I combine my like terms. And I'm like, okay, you know the question that's coming. Can I factor this? And if I can, even if it's a little tiny number like 2, I need to do that. You're like, why? Why do I need to keep going? Harty, it seems like nothing ever cancels with these. I do all this work, I do all this factoring, nothing cancels. And then you get to this problem and go, oh. And the rest is going to be my answer. So again, it's just something we want to work through, think about, try out, and keep going with until we get it. But the biggest thing again is I got to be able to find a common denominator. I got to be able to build my numerator. Those are the 2 things that are just musts with this. Okay, and again, you can use this moving forward, so keep it in a safe spot. Okay, last one on the help sheet. Yes, these both factor. It's going to be a rare occasion when that doesn't occur. And another reason why you need to be able to factor. Now here we get another unique situation. And this is what was talked about up above on step 3 of our building an LCD. So now that you've had a second here to think about our little dilemma here. It's not really a dilemma in our second fraction. But if I have 2 of the same quantity, 2 of the same parenthesis, I'm going to want to write it this way. Well, why do I have to write it that way? Why can't I just leave it as x minus 5, x minus 5? Because if you remember, up in our third step of building, it says never use squared unless the same set of parentheses is found in one fraction, x minus 5 and x minus 5. I think that fills the definition here. So my LCD for this one would be x plus 2 and x minus 5 squared, because we take the largest exponent, that we see in a single term. Much easier when you can actually see it. So I go to build. And as I get ready to build this, again, I just keep reminding myself of what the goal in mind here is. To get from that old denominator to my new one. So, I got the x plus 2. I have one x minus 5, but I need 2 of them. And again, if working this horizontally like we did up in the first one is a better route for you, by all means do it, okay? There's no correct way. It's got to be the way that you find that works for you. And then finally here, I have the x minus 5 squared. I need the x plus 2. Cleanup time. Okay, we're going to try and go one fraction this time. We got this. Bump this up a bit so we can actually see what's going on. Okay. So here I've got 5x minus 25. And over here I have 6x plus 12. And with the plus, I'm going to combine like terms. You know, if I had minus, I'd have to distribute that negative through. I have 11x minus 13, which is not factorable. So that's done. Now again, keep this in a place where you've got a reference, where you can kind of try to figure this out. You've got to fight through this. No, this is not easy. Okay? It's not, but you've got to fight through. So what I want to do to continue to help this, and to continue to give you more examples to see that you actually could do this, we're going to move this out of the way. And we're going to jump into the extra practice. And I've selected a few on here that we're going to take a peek at. Your reminder, your 3 steps are up above. Number 1, we're going to start easy. Why is it easy? Because there's a common denominator already. Like that. So 30x to the 5th, I'm going to leave that alone. Now I'm just going to combine like terms. X plus x, not times x plus x is 2x. Negative 4y plus 6y is 2y. You know what questions come in. I can already hear somebody going, am I done yet? Yeah, that's the question. Are you done yet? No, you're not done yet. So let's see here. What do my 2 terms in the numerator have in common? Both have a 2. And again, this is why we always factor at the end. Because now when I look and I notice, hey, check this out. I can reduce that. And that'd be 1. If you want to put a 1 in front of the x plus y, you could. You don't have to. And a 15. Again, in parentheses, not in parentheses. Can't cancel those. That's as far as I can go. That's the type of thought process that I've got to work through as I'm doing these. Okay? And again, I want to make sure you've got a good example on here of each of the different types. So we're going to move down to number 6. Again, cover up. Factorable denominator, yes. I can get a 3 out of both of those. Let me get that out of there. All right, let's build this Coefficients. Yes, they're both 3. So, count by 3 and count by 3. I think that'd be 3. No single variables. One set of parentheses, one quantity. So I start my fraction builder game at this point. And we're kind of happy on the first one. First one, I go and I'm looking, I'm like, hey, it's the exact same thing. Okay, I don't need to add a thing to it then. We already got that part of the puzzle complete. But the second one, I got some work to do. I got the 3. I do not have the 3x plus 4. And again, no canceling yet. So, I'm going to clean this up a little bit. Give myself a little side work here. See what that's going to be. Now I can go ahead and see if I'm going to be able to do anything fancy with this or not. 6x plus 12x is 18x. Negative 4 plus 16 is a positive 12. And do I really even have to ask the question? Yeah, I didn't think so. What do those two terms have in common? Hopefully somebody said 6. If you said something smaller like 2 or 3, that'd be okay, but it's not going to get you your biggest value out. So 6 and again, now I have those coefficients in front where I can reduce this. 6 divided by 3 is 2. Larger values up in the numerator, so that's where the 2 stays. And no, I cannot cancel the 3 x's. They are bonded. Unless these are identical, I can't go any further. Those are the types of things that we're on the lookout for. But again, the only way it gets better is with time and practice. If nothing else, go through and just find the common denominator for every one of the problems if you're not going to do the rest for right now, but do something to reinforce the topic. Okay, those should have parentheses. I'll put them in since they don't. This should be like the easiest LCD that we have all sheet, probably. Well, besides the ones that are identical. No coefficients. No single variable terms. Now, there's a little work when I get to the building part. Because again, I don't have everything I need. There's my missing piece. Old to new. Whatever's not checked, whatever's missing. Multiply that through. And again, I'm understanding to the point where you don't want to have to rewrite this 10 times. It takes up a lot of space. It takes up more time. I get it. But then you need to do your work somewhere on a side so you can kind of see how this goes. So I'll just do mine up here. So I got 5v minus 15. And then here I've got 6v squared plus 36v. Because again, I'm distributing on both of these. And now I'm just going to write it in the correct order. Okay, which is the largest degree down to the smallest. So 6v squared plus 41v minus 15. And I'll even be nice again. This isn't going to be factorable. Okay, just giving you a heads up. So I get that out there, and we're going good. So now as we keep moving forward, and again, we keep seeing little things. Sometimes I have a coefficient, sometimes I don't. Sometimes I have things that are factorable, sometimes I don't. Biggest thing, make sure that I'm factoring things correctly, because if I don't, that can get to be a little bit of a dilemma. So I get to here, and I go, okay. LCD, going to be a little larger this time, because I have a coefficient, I have some single variable terms. And I'm going to do something a little sneaky here. So I start to look at my builder mode. And I'm like, okay, check. Before you write all of this up there, let's think about this for a second. N minus 6, N minus 1. If I put that up here, I'm going to have to box it or foil it back out, right? But isn't that the same as what I just had here? Now, I can box or foil it out. I'll get to the same answer. But if you notice, it's the exact same you got from just factoring one of your terms. If you can still see it, and I can on mine, I'm going to go ahead and just write it in there in the factored form already. I'm going to save myself a step. Now, if you don't, it doesn't kill you. You're just going to box or foil it out and get there anyway. And then here, I got the factored form. I just would write this form back in. So now, I get that set. I do my distributing. There actually are no like terms up there to put together. And they don't even have a number in common I can do anything with. So I'm set. And again, those are all bonded. Do not try to cancel the end of the thirds. Okay? Don't do it. Again, keep building as you go. Keep checking answers. Keep trying to work things again and see how it's going. Okay, a couple more we're going to take a peek at on the back here. And I'll get you let loose. All right, 13 and 15, and then I am out of the way here. Okay, 13. Parentheses here. Common, yes. All right, here we go. I'm going to try to get the long dramatic pause here to see how we're doing on things. Write down what you think the LCD is going to be on this one. Remember, go over your checklist as you're doing it to make sure you're covering everything. Okay, here's what your LCD should be. Like, wait, where's the 6 coming from? Again, count by 2s and count by 3s. What's the first number to show up in both lists? 6. And I have my set of parentheses. So now, I'm ready to build. Got the 5p plus 3. What do I have to times 3 by to get to 6? 2, okay. Let's divide it by 2. Over here, life's a little more complex. 2 times what to get to 6? That'd be 3. And I didn't check off the 5p plus 3, so I got to get that multiplied in there. And again, we're going to be doing some side work with this. So I do my distributing. Okay, so here I've got 2p plus 8. Now over here, 6 times 3 is 18. So I'm going to go ahead and I'm going to be like, okay, so 18, 5p plus 3. And I'm going to work that out. So 90p plus 54. Whew, that's a big old number, if I do say so myself. So I start to take a peek. So let's see here. We got 2 plus 90 would be 92p. 8 and 54 is 62. I think this is going to reduce. Let's see here. What goes into both of those? Uh-oh. Oh, I see see, this is what happens when you don't pay attention to the details. What did I do? You're like, seriously, Harty? Oh, yeah. I paid no attention to the fact this negative was here, which makes this a negative 90 and this a negative 54. You're like, so this is wrong? Unfortunately, it is. Bummer. So let's see. 2 minus 90 is negative 88. P. 8 minus 54 is negative 46. You're like, it's going to reduce, isn't it? So you even took up that room, and now it's still going to end up reducing. Well, We're going to get creative here. Okay. See, even it happens to me sometimes when I'm not paying attention. So don't feel alone with this. So let's see. I think 2 is the biggest number I'm getting out of both of those. It is. So I'll take out a 2. You could take out a -2 if you wanted to. It wouldn't hurt. All right, we don't have to worry about that stuff anymore, but this does reduce. 6 divided by 2 is 3. Bigger values down in the denominator. So that's where my solution is going to go. Whew. Survived. Okay. But again, sometimes life is about trial and error, and it's not fun to make a mistake. It's not fun to take up time that way, but it helps us to pay more attention to the details, and hopefully I won't do that again on 15 because I notice there's a minus in the middle. All right, last one I'm playing with you here. Then you get to practice some on your own. Get my parentheses in here. All right, LCD, coefficient, single variable, quantity. So I'm going to go ahead. That's set. I need the 4x. Here I got the 4x. I need the 5x minus 6. Now I have learned my lesson from number 13. Got this. 12x squared on my first term. 3 times 4 is 12. X times x is x squared. Then here, remember, this is like having a -2 that I'm distributing through. So -2 times 5 is -10x. And -2 times -6 is +12. So let's see, I got 12x squared minus 10x plus 12 over all this goodness, and no, it is not time to go. No, no, no. Sorry that you had to survive that. Okay, these each have a 2 in common. You're like, whew. So I get that factored. I take one last look and I say, ooh. And reduce that part. So finally, we get to the answer. Where am I going to put it? See, I took up that extra room. No. I got room. 6x squared minus 5x plus 6 over 2x, x minus 6. Okay, so again, we knocked out almost half of this. We knocked out some ugly ones, we knocked out some kind of easier ones. Take this last 20 minutes or so, and again, just reinforce some of it. If we got to play with some more of it again tomorrow, we do, that's okay. But you've got to put in the effort now to reinforce it yourself, or you're setting yourself up for some bad stuff moving ahead. See you tomorrow.